Playing pool with your friends, do you want to lose aura or gain aura in front of them? I'm sure the answer is clear, the latter. We will be investigating the physics of pool, and my group members are Lucius, myself Dexter, Kai Bo, and Cheng Kai, and we will be doing this for the topic for our physics alternative assessment. So, let me now share with you the background of our problem. So, me and my friends actually do love to play pool, and we realize that pool relies on precision and physics concepts, and these key concepts include linear momentum, energy conservation, collision behavior, and Newton's laws and laws of reflection. So we decided that for our AA we want to do something fun, and we know that pool also has some physics concepts. Therefore, we decided to make this as the topic of our physics alternative assessment. So our research objective is to understand how physics can be related to the game of pool, and also learn to have fun while learning physics. So some logistics that we require are the pool table, the cue ball, and other balls that act as object balls or obstacle balls. So now let me show you the overview of some of the shots that we will be discussing. First up, we have the stop shot where the cue ball stops immediately upon impact, which is to show elastic collision. We have the ghost ball where the cue ball collides with a ball in between to hit the object ball, which also shows elastic collision. And also the principle of conservation of momentum, which is MAUA plus MBUB equals to MAVA plus MBVB, where in a given system, taking for example the cue balls, the momentum before is equals to the momentum after. And we have the jump shot, which makes the cue ball jump over an obstacle, for example an opponent ball, to prevent a free ball to contact with the object ball. Because sometimes there are no other ways for you to hit your object ball on the cue table, so you have to make a jump shot. And next we have slicing, where the cue ball is aimed to hit the object ball off center, so that the object ball travels at an angle into a pocket. And lastly, we have the reflection, which is hitting the cue ball at the railing at an angle to hit the object ball. Now, I'll pass over the time to Lucius to explain in depth for these shots.
Now, moving on to the type of shots. The first shot is called the stop shot. The stop shot illustrates the concept of elastic collision. Well, almost, since it is not ideal. When the cue ball hits the ball, it transfers almost all of its kinetic energy and momentum to the object ball. The cue ball stops moving while the object ball travels forward. Next, we have the ghost ball. The ghost ball also illustrates the concept of an elastic collision, but with another ball in between. Cue ball first strikes the first ball, transferring most of its kinetic energy and momentum, and the first ball travels and hits the second, transferring most of its kinetic energy and momentum to the second object ball. The second object ball then travels forward. Do note that these shots are given by the principle of conservation of momentum. The principle of conservation of momentum is given by the formula MAUA plus MBUB equals to MAVA plus MBVB. Most of the first few shots use this concept where the total momentum of a closed system, where there are no external resultant forces, remains the same. Next, we have the jump shot. The jump shot is also Newton's laws at work. By striking the cue ball below its center, a downward force is created, resulting in an upward reaction force that causes the ball to jump. Next, we have a technique called slicing. Slicing is a technique used in pool to pocket a ball that isn't in a straight line to the cue ball. By hitting the cue ball at an angle, the direction of the force exerted on the ball will point towards the pocket, pocketing the ball. This is of course the resolution of forces. Next, we have the reflection shot. The reflection shot is made by bouncing the cue ball against the rail. It is used when balls of different groups are in the way and there is enough space for the cue ball to travel. It follows the law of reflection where the angle of incidence equals the angle of reflection. So, in conclusion, there is of course potential to improve your pool skills using physics. For example, hitting the rail at an angle, so the angle of incidence equals the angle of reflection, which is of course your reflection shot, And this, of course, demonstrates the value of experimental physics that is not just theoretical, but can be applied in real life. Thank you.
Oh,